So today we're going to take a look at graphs of functions. Some of this is identifying, in fact most of it is identifying what's happening in a graph. To start with, we've just been talking about this, but to remember, f of x equals y means that if we had values plugged in, f of 3 equals 4, all it means is x is 3 and y is 4. That's what that notation means. I feel like sometimes notation is half the battle. If you can interpret the notation in words, you can probably answer the question. But if you get stuck, kind of up a creek. So we've got to keep remembering what the notation means. 3 is the x, 4 is the y here. Throughout this lesson, there's going to be some graphs that you're going to have to sort of transpose into your notes. So you might want to do your best to sketch them, and then go back and watch this video to get the details in there, okay? So let me show you what I mean. Here's our first one. We're going to consider this graph, and we're going to find a couple of values. Part A says, find f of -3. What is -3 in this spot? Is it x or is it y? It's x. So this is telling me x equals -3. So what is the question asking me to find? Asking me to find y. Okay, these are always going to tell me one of the two. Whichever one it's telling me, it's asking me to find the other one. So this is saying x is equal to -3. Find y. So over here on my graph, you've got an xy number line, right? This is my x-axis, the horizontal one. And on the x-axis, you can find the location for -3. Yep? Okay, so it's right here. I'm pointing to the -3. That's on the xy axis. That's not on my graph. My graph is the part that's in blue on my screen, right? So on my screen, if I'm at my x value of -3, I'm right down here on my graph. That's the area of my graph where the x value is -3. Does that make sense to everyone? So then, on that spot of my graph, what y value is corresponding to -3 for x? It's -4, right? -4. So the y value that I'm looking for here, f of -3, is equal to the y value of -4. There's no work to show, which means there's also no partial credit. But if you can write yourself down or even just think through the language carefully, you'll have the right piece of information. How about on B? It actually is a little bit nicer because it says to find the x value, right? Which means that the value they're giving you must actually be y, right? They're giving you the y value and they're telling you to find the x value. Now, on this particular graph, there's more than one place for that to happen. So here's the y value of 2, correct? On the axes. So if I were to trace over to where I see parts of the blue happening, it's here and here. Agreed? So there's actually two answers to this that would both be correct, because this says simply to find one value, one x value, where I have a y value of 2. So what are the two possible answers here? What could I write down? Either of these answers would be correct because the x value, that's not what I wanted, this one, here is -1, and the x value here looks like it's at -4. Pretty close anyway. So you don't have to write both of them down. I just want you to know that there are two answers to this, and either one's fine. Now, last class period, I introduced some notation to you. The notation I introduced was the words domain and range. We talked about domain being the input values, or the x values, and the range being the output values, or the y values. So we used that language last time. Not a lot, but we did talk about it. What we're going to do next with it is we're going to look at a graph again. This is all graphing today. Look at a graph and identify those pieces of information. From the graph, what's the domain? From the graph, what's the range? So here's our first one. There's first two, actually. Number 2 is just a bunch of dots, and that's totally fine. We can have a graph that is discrete points. Discrete means individual. They're not connected. Okay? That's a possibility. When that's the case, in fact, in all these cases, I'm just going to identify D with a colon and R with a colon to say which one's my domain and range. If you want to write it out more, elegantly, more description, go for it, but this is sufficient. The domain is which? Is it X or is it Y? The domain is X. So on this graph, there are only a few points. So there are only a few X values. When I'm listing them, I can actually write them in curly braces and just list them. You can't write this in parentheses, okay? Because parentheses means we have ordered pairs or intervals. We don't. We just have a list of values. What X values do you see present on these 4 blue dots? An X value of 1, sure. What else? There's 2 of those, but I only need to write it down 1 time. If you write it twice, it's fine, but it's not necessary. There's an X value of 4, and an X value of -4. So again, this is the X values that I'm seeing. And if I go up and down to the blue dots, there's where I have dots. Now we're going to look at the range values. What Y values do you see? Oh, and this closes with a curly brace. Sorry about that. What Y values do you see present on this graph? 0, 3, -4, and +4. And hopefully you noticed that I just took the values from you as you gave them to me and I wrote them down. They don't have to be in any specific order, okay? Because they're just individual points. Number 3. Number 3 has a starting place and it has an ending place and it has a connected curve between, right? So what you see happening on this one is that there are infinitely many X values and there are infinitely many Y values, which means I can't list them all like I just did. Does that make sense to everyone? So on this one, it makes sense to say, where does it start? What's the smallest thing? And where does it end? What's the biggest thing? So for my domain here, what I want to think about is I want to think about walking along the x-axis. So if I start walking at the far left, where I've put my x, and I keep walking, I'm looking up and down and up and down. What is the first x value that I come to where I actually see part of my graph? -2. So once I get to here and I look up, I see blue, right? The blue solid dot, in fact. So remember we did number lines where I used parentheses and brackets, and I also told you that you could use open circles and closed circles, right? When you do it in 2 dimensions, you have to use open circles and closed circles. Parentheses and brackets look weird. So you see open circles and closed circles. The closed circle corresponded to the bracket, right? So I'm going to open this with a bracket and a -2. And I keep walking along. So like I'm on the x-axis, right? And I'm going to keep walking along, and I'm looking up and down like this. And at some point, I stop seeing my function. I stop seeing the blue curve. Where is that happening? At 4. At the x value of 4. And there's an open circle there, right? Oh, it's at 3. My bad. I was taking your answer. I think the y value you're seeing is 4. Is that true? Yes. Here. Yeah? Are you guys good with that? Okay, the x value of 3. Well, you're going to do the y value here in just a second, but x value of 3. And at that x value of 3, I have an open circle, yeah? So what did I have corresponding to the open circles when I did number lines? Parentheses. So I'll have a parenthesis for that one. Okay, so x values, domains, I'm walking from left to right across my graph. Y values, range. I'm going to climb a ladder. Where do you start when you climb a ladder? At the bottom, right? You start at the bottom. So I'm starting at the bottom of my graph. And I'm climbing up. And as I climb up, instead of looking up and down, because I'm climbing up, I'm going to look left and right. And the question is, as I climb up my ladder, what is the first y value that I see? I think I see it at is it -3? Yeah, it is at -3. My numbers are covered up at this point. Here we go. That spot right there, yeah? So at that point, I look to this right-hand side, and I see a value. And it's -3. And it's a parenthesis. So I put it's an open circle. I was trying to, say it so you just had to say something. That didn't work at all. You open circle, so you use a parenthesis, right? It's all right. And I keep climbing up the ladder. And where is the point where I stop seeing values? It's at 2. At my x value right here of 2, I stop seeing values. It's my furthest up point. And will I use a parenthesis or a bracket there? A bracket, because it is a closed circle. Does that make sense? We're walking along the x-axis, we're climbing up the y-axis. That's domain and range. I want to do another one with you, though. Looks a little bit different. Okay. There's 2 pieces of this graph, right? They're not connected. But the pieces themselves have a range of values. Like I have a bunch of connected values, and then I have a break in the graph, and then there's a bunch of other connected values in another piece, right? It almost feels like there's 2 different graphs going on. Does that make sense to everyone? I do the problem the same way. I'm still walking along the x-axis. I'm still going to be climbing up the y-axis, okay? So we're going to do x-axis first. That's my domain. Start on the far left of the x-axis, and I'm walking along. What x value is where I first see part of my blue curve? At -5. And at -5, do I have a parenthesis or a bracket? What is it? It's a bracket because it's a closed circle. So I'm going to keep walking along. And eventually I'm going to stop seeing, for a while, values. What value is where I stop seeing blue parts of my curve? It's at -4, right here, yeah? So from here to here, as I'm walking, looking up and down, I see values. Yes? -4, I stop seeing values. So I'm going to stop the values at -4, and I'm going to close that off with a parenthesis because it's an open circle. But I'm going to keep walking. Keep moving to the right. And as I do, eventually I start seeing values again. At what x value do I start seeing parts of my curve? At -1, right here. And do I use a parenthesis or a bracket at -1? A bracket. Because I have a solid circle. It's closed in. And I keep going. And as I keep going, oops, where do I have to stop? At 2. At 2, I stop seeing values again. Are you guys good? Yeah? You are now. Okay. Will I use a parenthesis or a bracket at 2? A bracket. I will use the bracket. All right. Range. I'm going to climb a ladder. And I'm going to be looking left and right. Start here and I go up. What's the first y value where I see parts of the blue curve? It's at -3. Will I have a parenthesis or a bracket? A bracket. And I keep climbing up. And while there are 2 pieces of the curve, the reality is that for the most part, it doesn't matter. Right? I either see one part of the curve or I see 2 pieces of the curve maybe, but there's no break in it like there was when I was moving from left to right. I just keep climbing up. And the whole time I'm actually going to be seeing this piece of the curve, right? I am. Part of the time I also see this piece. It duplicates. But where do I stop seeing values as I keep climbing? At 5. And will I have a parenthesis or a bracket there? A bracket. Yes, ma'am.
So, like, if the one on the left was to go higher than the one on the right, you'd take, like...
The higher point there. Yeah. So if, let's say, that this graph over here continued up like this, all the way to here, right, to maybe like 6, and it stopped instead, then we would continue up to 6. We'd see a different part of the graph, but we'd still be seeing the graph. Yep, you would. Even though they're from different pieces of the graph. Excellent questions, ladies. Yeah, because no matter what's happening, I'm still seeing part of the graph. There's no break in the graph values. I'm on a different piece of the graph, but the values are still present. All right. Shifting gears from domain and range. A slide with a bit of writing on it. We're going to talk about the behavior of a graph. A graph can behave in one of 3 ways on different portions or on all of the graph. It could be increasing, it could be decreasing, or it could be constant. first one, increasing, well, actually on all of them, increasing, decreasing, and constant, you see x1 less than x2. That's just telling you you're moving from left to right. So when you see my sort of verbal descriptions underneath, the from left to right, that part's corresponding to that x1 less than x2. I'm just going on the graph from the left to the right. It's the same way we read English. Do you know not all languages are read from left to right? They're not. I had a office mate in my grad school who was Chinese, and I think they read from right to left. There's something different about the way that they read, but we read from left to right. The other pieces of information that you see here are describing what the y values do. The first one says that your y values get bigger. That's what it says. y1 or f of x1 is less than f of x2. The y values are getting bigger. The second one says that f of x1 is greater than f of x2. That means the y values are getting smaller. And the last one says the y values are the same. They don't change. Correct. Yeah. So when you're thinking about them visually, increasing looks like you're going uphill. That's what it means, right? I'm going up. Decreasing looks like you're going downhill, going down. And constant means that it looks flat. It's just a consistent surface. It's a flat surface, like walking across, a lot of Oklahoma. It's flat. So this is the same graph you had on the last problem. So I'd encourage you not to redraw it. You don't need to. Just reference back to it. I've got mine again on here so we can see it on the same screen. But take a look at this one. There are two pieces of the graph, and they are doing different things, right? What's happening on that first piece? What's happening? Increasing, increasing, constant. Which one's it doing? I feel like all 16 of you or however many's here today know the answer. Nobody wants to say it. The piece that I circled, is it increasing, decreasing, or constant? It's decreasing. If you're going from left to right on the graph, it is going down. Correct? It's like a slide. Whee! Okay, so that, in fact, it looks a lot like the big tall slides at Whitewater. So the first piece is actually decreasing. And I've got a different example here in a minute to show you another way to write them. But typically speaking, when we're talking about identifying that the graph is decreasing or increasing, we talk about what x values it goes from and to. So the graph is starting here at an x value of what? -5. And it stops decreasing, right? The end of the slide is an x value of -4. Open circles are parentheses, closed circles are brackets. So this graph is decreasing from -5 to -4. What about the second piece of the graph? Again, we read from left to right. It's increasing. Okay, what x value does it begin increasing at? At -1. And it ends or stops increasing at an x value of what? 2. And those are both closed circles, I believe. Yeah. So we'll use brackets. Any questions on that one?
So you just use the domains?
Exactly. You use the values from the domain to make the distinction. All right, so I'm going to keep this recording. That way those who aren't here will also hear it. I have 2 lessons I'm going to hand out to you. I'll tell you where you can finish up until. I have the quiz already made to cover these 2 lessons of material. So what we're going to do is that the quiz is going to be on Friday. Okay, so I'm going to push the quiz away from Thursday to Friday. I'm also going to let you know that on Thursday, tomorrow, we will end class a little bit early. There is a gentleman in our church who passed away, and I need to be at his viewing because he's not having a funeral at a specific time. I have to be there at 1 o'clock, and it's in Edmond. So we'll be ending at 12 tomorrow for class. So we'll be doing just new material. We'll finish this lesson, and we'll do the next one, and we'll have the quiz on Friday. Okay?